Hey there, Mr. Sutton here with the IM3 Honors 1-4 Part 2 homework solutions on inverse functions. For number 8, we want the inverse of this cube root, and we know cube roots, they're going to pass the horizontal line test. So let's go ahead and switch x and y. To get y by itself, first thing we need to do is cube both sides. So we have x cubed equals y plus 8, and then just subtract 8. So f inverse equals x cubed minus 8. For number 9, we need the inverse of this weird rational function. Now because this has an x squared in it, even if you don't know what the graph of this looks like, you know that this x squared is going to make us lose information when we plug in negative numbers. We won't be able to get back to the negative numbers. So because of the x squared, this does not have an inverse. For number 10, finding an inverse for this, we have odd exponents only, so that means we are going to be able to find an inverse. So let's switch x and y. We have x equals 5th root of 9 over y to the 7th. Next step after that, we have to get rid of the 5th root by raising both sides to the 5th power. So x to the 5th equals 9 over y to the 7th. And then we need to get this y out of the denominator. So if I multiply by y to the 7th and divide by x to the 5th, I'll be able to do that. As a last step, to get rid of the 7th power, we just need to take the 7th root of both sides. So f inverse then equals the 7th root of 9 over x to the 5th. To find the inverse on this function, we're going to start by switching x and y. So I'll write this as x equals 5th root of y plus 1 over 2. And now I have to solve for y. First thing I need to do is get rid of this 5th root by taking the 5th power of both sides. So this will be x to the 5th equals y plus 1 over 2. Next, let me get rid of that 2 by multiplying both sides by 2. So we'll have 2x to the 5th over on the left side. And finally, we'll subtract 1 to get f inverse equals 2x to the 5th minus 1. For number 5, we're trying to find the inverse of this expression. Now we have an odd root. I mean, that doesn't really make a difference. Roots, even roots, odd roots, they have inverses. X to the 5th is okay. That doesn't hide what kind of input you had. So let's go ahead and take the inverse of this thing. We'll have x equals cube root of 10 plus y to the 5th. And we've got a few steps on this one. First, we have to get rid of this cube root by cubing both sides. So that's x cubed equals 10 plus y to the 5th. Then we have to subtract 10 from both sides to get y to the 5th by itself. Finally, we have to take the 5th root of both sides. So that'll give us f inverse equals 5th root of x cubed minus 10. For number 6, this is definitely going to have an inverse. If you were to graph this out, this is one of those two-branched rational kind of functions. It definitely has some places where it's undefined, but it passes the horizontal line test. So let's switch x and y. We'll have x equals 1 over y plus 6 plus 2. And then to get y by itself, first let's get this 2 to the side with the x here, so subtract it. And now we need to get y out of the denominator. In order to do this, one way you could do it is multiply both sides by y plus 6. That would bring it up here. At the same time, we don't want this x minus 2 hanging around, so we're going to divide both sides by x minus 2. So basically, you're switching y plus 6 and x minus 2. At this point, you just have to subtract 6 to get y by itself. So f inverse then equals 1 over x minus 2 minus 6. For number 7, we're trying to find this inverse. Now, I'm not sure exactly what this function looks like, but since it has this absolute value in here, I know that my negative and positive inputs are both going to turn into positive outputs, so I won't be able to work backwards to figure out what I started with. So this then does not have an inverse because of this absolute value.